In this segment, we're going to continue with the array model, except we're going to be multiplying two-digit numbers times two-digit numbers. Our question is going to be 13 times 12, or 13 sets of 12, or 12 sets of 13. And we're going to fill in our array here. And here's our array of 13 times 12. I want to point out a couple of things. When we take a look at this array at the top, I notice that my 10 is horizontal here, and here is vertical. And is that important? Would it be all right to put a 10 rod sideways here? If we were trying to get 12 down this side and we put it horizontally, it would look something like this, and it would only have a height of 1. Just like these ones down here only have a height of 1. So if we were to put this rod sideways, we'd have a height of 1, a height of 1, and a height of 1, and that would be a 3, and it wouldn't be 13. So it's very important for us to understand and convey to the students why the rows or why the rods are sometimes vertically and sometimes they're horizontally. That being said, if I have something that is 10 high and 10 across, that would give me an area of 100. I'm going to slide that in there, and we can see that this is 10 across, and it is 10 high. So the area of this piece here would be a 10 by 10, which would give me a 100 square. If we take a look at the bottom, I now have a height of 1, and I'm multiplying by a base of 10. So that's going to require me to produce a rod across the bottom with a height of 1 and a base of 10. I have another one right beside it, right here, and therefore that's going to require a height of 1 and a base of 10. When I go to take a look over here on the right hand side now, and I'm looking at these guys over here at the top, they have a height of 10 and a width of 1. So instead of putting in one of these rods that go this way, I have to now flip it so that I have a rod that goes vertically. And now I can put that in that space. It's got a height of 10, just like this one has a height of 10, and it's got a width of 1, just like this one has a width of 1. So this area is a 1 by 10 or a 10 rod. Just like that, we have another one of those right beside it, so we'll put that one there. And we have another one of those right beside it again, so we'll put another one right there. So now I've got my 10 times my 10s, my 10 times my 1s, but I haven't taken my 1 times my 1. So now I'm looking at something that has a height of 1 and a base of 1. So 1 times 1 is going to produce one of these little 1 squares. So I'll slide one of those in there, and I have to do it again and again for a total of 6 of these. And now in doing that, as I said before, any multiplication can be written as a rectangle. So here I have one big rectangle. And that's the answer to my question. So how do we read this? The big blue flat is a 100. So I'm just going to put that over here. So there's my 100. I've got 1, 2, 3, 4, 5 yellows. So each yellow is a 10 rod. So there's 1, there's 2, there's 3, there's 4, there's 5. So a total of 50, or 5 10s. And I've got 6 1s. 1, 2, 3, 4, 5, 6. And there's my 6 1s. And so when I add them all together, I get 156. So I just moved it over a little bit, give us some more space. So let's say a student wanted to do this question in a mental math strategy. They might use their doubles. So 13 times 12 is pretty close to a double that they hopefully know, which is the 12 times 12 double. And so if I go over here and I take a look at my question, here's 10 plus 2, 10 plus 2. If I just do this, what I've modeled there, or what I've selected, is basically the 12 times 12 question. And a student might, in a mental strategy, say, well, I know 12 times 12 is 144. And let's make sure that's true. There's 100, 10, 20, 30, 40, 1, 2, 3, 4. So I know my 12 times 12 is 144, and I have 12 left, 112 left over. And so I get the answer by doing something like this. I know my 12 times 12 is 144. There it is, in blue. I know 1 times 12 is left over because I had 13, but I've only used 12 of them. So 1 times 12 is an additional 12. There it is hanging out on the side there. And so for a total of 144 plus 12 is 156. But some kids can't do 144 plus 12 in their head. So they say I've got 144 plus a 10. That's 154 plus a 2. 156. And they can possibly do that in their head. So they can use the double strategy. And we can see the visual of the concrete connected to that double strategy that they use for mental math. Now a student might want to speed up this process. Instead of using all the blocks, they might want to use a bigger chunk and use the partition method. So our question might look like 10 plus 3 times 10 plus 2, and they're going to break that down into its chunks. So they might break it up this way. We've got 10 plus 3 and a 10 plus 2. The 10 piece is bigger than the 3 piece, and the 10 piece is bigger than the 2 piece. It's not quite to scale, but I don't have a lot of room here to do it, so I'm just going to do it like this. And then we just fill in each section. So up here in the corner, I've got my 10 times 10, and that is going to give me a piece here in the middle, which would be 100. Across the top, we now have 10 times the 3, and that piece is going to give me 30 here in that section right there. So there's my 30 piece. Oops. Here, I've got my 2 times the 10 piece, and so that gives me an answer of 20. That fits in that section there. And finally, in the bottom right-hand corner, I've got the 2 times 3 piece, and that gives me 6, and that goes into the bottom right there. So again, I have 100, 20, 30, and 6, which is 156, which ties in nicely to the 100 that I had here, plus 3 tens, which is our 30, plus our 2 tens, which is our 20, plus our 6 ones down here, which are 6 ones down here. And notice it's not by accident that the shape, the spacing and the lining up is still the same. Top left-hand corner is 100, just like it is in here. Top right-hand corner is 30, just like it is here. Bottom left-hand corner is our 20, just like it is here. And the bottom right-hand corner is our 6. Bottom right-hand corner there as it's 6. Let me just take a second to clean that up now. So we're trying to get to our standard algorithm of 13 times 12. But there's one more step I think it's important for students to see before we talk about the standard algorithm, and just make all the connections. We might want to start off with all these connections. We wouldn't do it every single time, but I think what happens is we tend to go to the concrete, think that they understand the concrete, they can automatically relate it to the symbolic. And I think we really have to take some time to show them the connections between the concrete or the picture to the symbolic that we're doing. So there's another intermediate step that I think is kind of important, and I'm going to show that to you now. I'm going to take that same question, I'm going to write it this way. 10 plus 3, there's our 13, and there's our 10 plus 2. We're going to write it like that, and we're going to multiply those two together. So we need a line, I guess. So we'll draw a little line. There's our line, and we'll go from there. Now, 2 times 3 is going to give us 6. So I'm just going to take that 6. Oops. I'm going to take that 6, and there's my 2 times 3. That's 6. Just move it up a little bit. Now, 2 times, it's not 2 times 1 as we see it here. It's actually 2 times 10, so the kids can see that that's 2 times 10. 2 times 10 is 20, and there's that 20 that we had right there. Then we have 10 times 3, which is 30. And when we do our standard algorithm, lots of times when we say, well, we put a 0 there. Why? Well, I'm not really sure why. Well, it becomes easy now that it's not 1 times 3, it's actually 10 times 3. So this is a nice connection, and the 10 times 3 piece gives me 30. So I can put that there in the 30s column. And 10 times 10 is 100, and I can take that 100 and stick it out here if I like. Once I've got the numbers in, it doesn't really matter what order I have them in. I could put them like this if I wanted, so that they all line up nicely. And we still get the answer of 156. Moving on to our standard algorithm, 2 times 3 is 6. So I'll put our 6 up there. And then we go 2 times 1 is 2. But what it really is, it's really a 20. But we could write it with over top. That's messy. So we tell students all we really have to do is put the 2, and that's going to give me 26. 2 times 13 is 26. Then we have this 0 that we tell students that they have to put it there. And lots of students, all the way up to university, still don't know why we have to put the 0 there. It just does. But when we go and we take a look that it's actually 10 times 3, we see that it's going to be a 30. So when we go 1 times 3 and put our 3 there, that's really our 30 that we're talking about. Then when we go 1 times 1, it's not 1 times 1, it's actually 10 times 10. Here's our 10 times 10. And so when we go to put our 1 here, we're not really putting a 1. What we're really doing is putting a 100. But we don't write the 100 often. We just write a 1. And then we take our answer and add them up. So we draw our little line again. And we add them up. And we say 6 and 0 is 6. 2 and 3 is 5, and 1 for 156. And we can connect with the student that the 26 that's right here is this 26 that fits right there. And this 130 that's there is actually this 130 together right there. And this algorithm is called the standard algorithm just because it's a little shorter, doesn't take quite so much space up as these ones do, and we tend to find the ones that are the most efficient and the quickest. Not necessarily the ones that make the most sense, but the ones that are the quickest and the most efficient. So we want to make sure that students understand what all the pieces are, where they come from, and I think we've done a pretty good job connecting the concrete piece to something in between, to a mental strategy, to an intermediate symbolic, to the standard algorithm finally that we've got going here.